Hey everyone, and welcome back to the Deep Dive. Today we are getting ready to explore the fascinating world of asteroid chemistry.
Oh, yeah.
Buckle up because we're about to uncover what these space rocks are really made of.
Mm,
And trust me, you're going to be that person at the party dropping all the cool asteroid facts.
I can't wait.
So let's kick things off with, you're the expert here.
Well, thanks for having me.
So excited to have you.
Yeah, it's exciting to delve into this topic because asteroids, they're like these little time capsules floating around out there,
They really are right.
holding secrets about how our solar system formed billions of years ago.
Billion years, it's hard to even fathom that.
It is.
So let's start with the basics, asteroid chemistry 101. What are these things made of? I mean, are we talking just like plain old rocks, or is there more to it?
Okay, so it's definitely more than just rocks. Asteroids are incredibly diverse in their makeup.
Okay.
And that's what makes them so fascinating. We're talking about a mix of rocks, metals, and minerals.
Like a whole salad of space stuff.
Exactly, each with its own unique story to tell.
Okay, so it's not a one-size-fits-all situation when it comes to asteroids.
Not at all.
Makes sense. I guess when you consider how they formed, billions of years ago in this chaotic early solar system.
Yeah, it was like a cosmic demolition derby back then.
Right. I mean, planets forming, smashing into each other. It must have been wild.
Absolutely. And asteroids are basically the leftovers from that era, the bits and pieces that never quite made it to become full-fledged planets.
Like the crumbs of planet formation.
Yeah, and their chemical makeup reflects all the different processes and conditions that were happening during that crazy time.
So we've got this cosmic blender whipping up all these ingredients,
Yeah,
and out pop these diverse asteroids.
exactly.
So tell me about the main types of asteroids we find out there.
Well, broadly speaking, we can categorize them into three main groups:
Okay.
metallic, stony, and carbonaceous.
3 flavors of asteroids. I like it.
Yeah, and each type has its own distinct characteristics that tell us something different about the solar system's history.
Okay, let's start with the metallic asteroids.
Sure.
Those sound pretty hardcore. Are we talking like giant chunks of iron just flying through space?
You got it. Metallic asteroids are like the heavyweights of the asteroid belt, mostly made up of iron and nickel, similar to what you'd find in Earth's core.
Wow.
They're thought to be the shattered remains of the cores of those early planets that were forming.
So like the exposed hearts of protoplanets ripped apart in some ancient cosmic collision. That's intense.
It is pretty dramatic.
It makes me think of asteroid mining.
Oh, yeah.
All those sci-fi movies where we're harvesting resources from space.
Right.
Is that something that's actually on the table?
It's definitely something that is being seriously considered. Metallic asteroids, with their high concentrations of iron, nickel, and other valuable metals, could be incredibly useful
Yeah.
for building things in space, developing new technologies, and even fueling future exploration. It's not just science fiction anymore. There are companies and agencies already working on developing the technology to actually mine asteroids.
Wow, that's amazing. So we've got metallic asteroids, those heavy hitters. Now, what about stony asteroids?
Okay, so stony asteroids are actually the off-common type out there.
Okay.
They're rich in silicate minerals, which is similar to what makes up the rocks we find here on Earth.
So they're kind of like the more familiar faces in the asteroid crowd.
Yeah, you could say that.
Giving us insights into the building blocks of rocky planets like our own.
Exactly. They provide valuable information about how terrestrial planets like Earth form and what they're made of.
Okay, so we've got the metal-rich asteroids, the rock-rich asteroids, and that leaves us with the carbonaceous asteroids. These sound a bit more mysterious. What's the story with those?
Oh, these are the ones that get scientists really excited.
Ooh, why is that?
Carbonaceous asteroids are unique because they contain organic molecules,
Okay.
water-rich minerals, and a whole bunch of other interesting compounds.
Wait, did you say organic molecules? As in the building blocks of life?
That's right.
I am suddenly very intrigued by these carbonaceous asteroids.
They're like cosmic treasure chests, packed with the potential ingredients for life itself.
Wow.
And they offer a glimpse into the conditions that might have existed when life first arose, not just on Earth, but potentially elsewhere, too.
That's mind-blowing.
It is.
So are scientists actually suggesting that life on Earth could have originated from these carbonaceous asteroids?
Well, it's a fascinating hypothesis that's definitely being explored. Imagine these asteroids loaded with organic molecules and water crashing into early Earth,
Right.
delivering the essential components for life to spark. It's a possibility we can't ignore.
It's incredible to think that these seemingly ordinary space rocks could be carrying the seeds of life across the cosmos. It really changes your whole perspective on things, doesn't it?
It really does, and it just goes to show how important it is that we study these asteroids in detail.
Yeah.
They're not just inert chunks of rock and metal, they're dynamic objects with stories to tell, secrets to reveal, and maybe even answers to some of humanity's biggest questions.
Okay, so we've got these 3 main types of asteroids, each with its own unique story to tell.
Right.
But how exactly do these different compositions help us understand the formation of our solar system as a whole?
It's like piecing together a giant cosmic jigsaw puzzle.
Okay, I like that analogy.
By studying the distribution, the composition, the orbital characteristics of all these different asteroids,
Hmm.
we can start to reconstruct what happened billions of years ago when the solar system was taking shape.
So it's like using these asteroid remnants as clues to decipher the early chapters of the solar system's history.
Exactly.
What kind of insights can we glean from these cosmic detectives?
Well, for example, the fact that we find so many metallic asteroids in the inner asteroid belt suggests that this region was once much hotter,
Okay.
hot enough to melt metals and allow them to separate out.
Hmm.
On the other hand, the presence of water-rich carbonaceous asteroids in the outer belt tells us that this region was colder
Right.
and better suited for preserving things like water ice.
So by looking at where these different types of asteroids are located, we're getting a sense of the temperature gradients and chemical variations that existed in the early solar system. It's like creating a thermal map of the solar system's nursery.
Exactly, and by analyzing the specific composition of individual asteroids, we can learn even more about the processes that led to their formation.
Like what?
Well, for instance, the presence of chondrules.
Chondrules.
Yeah, these tiny spherical grains found in many asteroids, they suggest that these asteroids experienced rapid heating and cooling events,
Oh, wow.
possibly during collisions or when they were first forming in the solar nebula.
So we're building a forensic timeline of the solar system's birth, using these asteroid fragments as witnesses.
Pretty much.
That's incredible. It's amazing how we can extract so much information from these seemingly simple objects.
It really speaks to the power of scientific inquiry and how everything in the universe is connected.
Yeah.
These asteroids, once thought of as just debris, are now revealing themselves to be invaluable windows into the past, present, and future of our solar system.
So we've established that asteroids are far from boring. They're diverse, complex, full of surprises. But beyond their scientific value, how might these asteroids actually impact the future of space exploration and even humanity itself?
Well, as we touched on earlier, asteroid mining has the potential to revolutionize how we access resources and build infrastructure in space.
Right?
It could usher in a whole new era of space industrialization and allow us to expand human presence beyond Earth in ways we can only dream of right now.
It's like we're on the verge of a new space age one, where asteroids become stepping stones to the stars.
Yeah.
But before we get too carried away with these grand visions of spacefaring civilizations, let's talk about a more immediate concern, planetary defense.
Right.
How does understanding asteroid composition help us protect Earth from a potential impact?
That's a crucial question. Knowing what an asteroid is made of is essential for developing effective planetary defense strategies. Different materials respond differently to deflection methods, so understanding an asteroid's makeup helps us figure out the best way to nudge it off course.
So it's not just about blowing up an asteroid Hollywood style.
No, not really. Blowing up an asteroid might seem like the most dramatic solution,
Yeah.
but it could actually create more problems by generating a bunch of smaller but still potentially dangerous fragments.
Oh, that makes sense.
We need a more controlled approach, and that starts with knowing what we're dealing with. Is it a dense metallic asteroid? A porous rocky one? A loosely bound rubble pile? Each type requires a different strategy.
So it's like reading the instruction manual for dealing with a potentially hazardous space rock.
Exactly, and it's not just about avoiding impacts. Knowing an asteroid's composition can also help us assess its potential as a resource,
Okay?
or even as a stepping stone for future missions.
So it's not just about avoiding disaster, it's also about unlocking opportunities.
Precisely, asteroids with their diverse compositions and orbital characteristics,
Yeah.
they offer a wealth of possibilities for scientific discovery, resource utilization, and even future human exploration.
Wow.
They truly are the hidden gems of the solar system.
You've definitely opened my eyes to the amazing world of asteroids. I'm no longer seeing them as just random rocks floating in space.
Good.
They're time capsules, resource hubs, potential threats, and maybe even the key to understanding life itself.
It's amazing what we can learn from them.
It really is.
It's the beauty of science. It constantly challenges our assumptions and shows us how interconnected everything in the universe truly is.
I love that.
It's remarkable how quickly our understanding of asteroids is evolving. New missions and analytical techniques are constantly revealing new insights, challenging our assumptions and opening up new possibilities.
Yeah, it's not just about looking through telescopes anymore. We're actually sending spacecraft to asteroids, collecting samples and bringing them back to Earth for analysis. It's like having pieces of the solar system delivered right to our doorstep.
Exactly. Missions like OSIRIS-REx and Hayabusa 2, which brought back samples from the carbonaceous asteroids Bennu and Ryugu, respectively, are giving us unprecedented access to these celestial time capsules. We're able to study their composition in incredible detail, looking for clues about their formation, their potential to harder life, and even their potential as resources.
So we've got these samples back on Earth. What are scientists finding? Are they living up to the hype?
They're exceeding expectations. For instance, the analysis of samples from Ryugu confirmed the presence of water and a variety of organic molecules, including amino acids, the building blocks of proteins. This discovery supports the idea that asteroids could have played a role in delivering the ingredients for life to early Earth.
So those carbonaceous asteroids are really living up to their reputation as potential sources of life's building blocks. It's mind-boggling to think that these seemingly inert space rocks could be so intimately connected to the origins of life.
It really is, and the discoveries keep coming. The analysis of Bennu samples revealed the presence of carbon in a form that scientists didn't expect to find. This suggests that Bennu might have interaction with water in its past, adding another layer to the story of this fascinating asteroid.
It sounds like every sample we bring back opens up a whole new chapter in the asteroid saga. It's like reading a cosmic detective novel with each clue leading us closer to understanding the mysteries of our solar system. But besides their connection to the origins of life, how else might these samples shape our understanding of the solar system's history?
Well, they're also providing insights into the processes that shape the planets, including Earth. By studying the composition of these asteroids, we can get a better understanding of the conditions that existed in the early solar system and how those conditions influence the formation and evolution of the planets.
So it's like using these asteroid samples as proxies for the material that was swirling around billions of years ago, the same material that eventually coalesced to form the planets.
Exactly. For instance, by analyzing the isotopic ratios of elements in asteroid samples, we can determine where in the solar system they formed and how they might have migrated over time. This helps us refine our models of planetary formation and understand how the solar system evolved into the configuration we see today.
It's amazing how these tiny fragments of rock and dust can unlock such grand narratives about the history of our solar system. It's like having a time machine in a laboratory. But it's not just about the past, right? These asteroid samples also hold potential for the future, especially when it comes to space exploration and resource utilization.
Absolutely. The study of asteroid composition is crucial for identifying potential targets for asteroid mining. By understanding which asteroids are rich in valuable resources, we can prioritize those that are most promising for future missions.
So we're not just blindly going after any asteroid we can find. We're strategically targeting those that are most likely to yield a good return on investment, so to speak.
Exactly. We're looking for asteroids that are rich in water metals and other valuable materials that can be used to support human presence in space. Imagine being able to extract water from an asteroid to produce rocket fuel or to sustain a lunar or Martian base.
It sounds like we're on the cusp of a new era of space exploration, one where asteroids become not just objects of scientific curiosity, but also essential hubs for resource extraction and infrastructure development.
It's a vision that's becoming increasingly realistic, and it's a vision that's being driven in part by the insights we're gaining from the study of asteroid chemistry.
Okay, so we've talked about how asteroid samples are helping us understand the past and shape the future. But what about the present? Are there any practical applications of asteroid chemistry that are relevant to our lives here on Earth today?
Believe it or not, there are. For instance, the study of meteorites, those asteroid fragments that have fallen to Earth, is providing insights into the origin of life and the formation of our planet, but it's also helping us develop new technologies and materials.
Oh, that's interesting. I hadn't thought about the connection between asteroid chemistry and material science. How exactly does that work?
Well, meteorites often contain unique minerals and alloys that have formed under extreme conditions in space. By studying these materials, scientists are learning how to create new, high-performance materials that are stronger, lighter, and more durable than anything we can produce on Earth.
So we're talking about materials that could revolutionize industries like aerospace construction and manufacturing. It's incredible to think that these space rocks could be the inspiration for cutting-edge technology here on Earth.
It's a great example of how fundamental scientific research can lead to unexpected and practical applications, and it highlights the importance of continued investment in space exploration and the study of asteroids.
You're absolutely right. It's clear that asteroids are far more than just inert chunks of rock and metal. They're time capsules, resource hubs, potential threats, and even sources of inspiration for technological innovation. It's amazing how much we've learned about these celestial wanderers in recent years, and I'm sure there are many more surprises waiting to be uncovered.
I completely agree. The field of asteroid chemistry is rapidly advancing, and with each new discovery, we're gaining a deeper appreciation for the complexity and wonder of these objects, and who knows what other secrets they hold, just waiting to be revealed by future missions and scientific breakthroughs.
Wow. It has been a wild ride exploring the world of asteroid chemistry with you.
It has.
We've covered so much from basic composition to how they could revolutionize space exploration and even impact industries right here on Earth.
Absolutely.
But before we wrap things up, I want to circle back to something we talked about earlier.
Sure.
The idea of asteroids as potential sources of life's building blocks. It's such a mind-boggling concept, and I'm really curious to dive a little deeper into the research happening in this area.
It is one of the most exciting areas in astrobiology right now.
Definitely.
As we discussed, carbonaceous asteroids are especially interesting because they have those organic molecules, water, and the other key ingredients for life. But the big question is, did these asteroids just deliver those ingredients to Earth, or could they have actually hosted life themselves at some point?
Right, like were they just delivery tricks, or were they more like cosmic nurseries where life could actually emerge and evolve?
Exactly. That's the question driving a lot of research right now. And while we haven't found definitive proof of past life on asteroids, there are some pretty intriguing clues.
Like what?
Well, for example, some carbonaceous asteroids show signs of hydrothermal activity.
Hydrothermal activity.
Yeah, basically it means they had liquid water circulating within them, interacting with rocks and minerals.
So environments kind of similar to those hydrothermal vents on Earth, the ones that are teeming with life even without sunlight.
Exactly, and these hydrothermal systems on asteroids could have existed for millions or even billions of years.
Wow.
Plenty of time for life to emerge and potentially evolve.
It's mind-blowing to think that life might have existed or even thrived on these seemingly barren space rocks. So what kind of life are we talking about here? Are we imagining little green aliens or something more like microscopic organisms?
It's much more likely we're talking about simple, single-celled organisms similar to the very earliest life forms we see on Earth.
Okay.
Think bacteria or archaea organisms that can survive in really extreme environments like those found on asteroids.
So not complex ecosystems or anything, but the very basic building blocks of life taking hold in these unexpected, challenging environments.
Right. It really shows how resilient and adaptable life is, finding ways to exist in even the most extreme conditions.
Absolutely. And it really makes you think about the possibilities for life beyond Earth. If life could pop up on asteroids, it could be way more widespread in the universe than we ever thought.
It's a humbling thought, and it just underscores why exploration and research are so important, not just to understand our solar system's history, but to see what else is out there.
I completely agree. And the study of asteroid chemistry is a huge part of that.
Absolutely.
Hey, understanding what these objects are made of, we can figure out which ones might have hosted life in the past or could even be harboring life today.
For sure.
Well, I think we've given our listeners a lot to chew on today.
I hope so.
We've explored the different types of asteroids, how they form their potential as resources and threats, and even their connection to the origins of life.
It has been a pleasure delving into this topic with you.
Absolutely.
I hope we've inspired our listeners to look up at the night sky with a renewed sense of wonder and curiosity, knowing that even those tiny points of light hold incredible secrets just waiting to be uncovered.
Perfectly said. So to everyone listening, keep exploring, keep learning, and never lose that cosmic spark. Who knows what amazing discoveries await us as we continue to unravel the mysteries of the universe, one asteroid at a time.